Let's say you find shader graph confusing to read or hard to manage. Then I would say you are a programming person at the heart. Deep down, you always wanted to write shaders, but finds the documentation a bit lacking. Then I would say you are at the right place. Today I will show you how to write shaders from the scratch. For the tutorial, I will use Unity 6 and my project is set up in URP. I'm Digvijaysinh Gohil, and I know this will be a little bit late, but Happy New Year. Alright, let's get started. Alright, I have this scene. Now first I will create a shader, so right click, create, shader. Let's give unlit shader. I will call it my URP unlit and double click to open it up. Here I have some code which I'll just delete. Now in Unity we write shaders using two languages, ShaderLab and HLSL. ShaderLab is Unity specific language and is used to define the structure and the metadata of our shader, and HLSL is the language where we write the actual shader instructions. Alright, we will start off with ShaderLab, so I'll just go shader, then I'll give the name of my shader, my URP unlit, and here I can also define the categories, so I could go custom slash and then just open close curly braces. Now here I can define property block where I can define the material property which can be tweaked from the inspector. But for now I'm not going to use any properties, so I'll just comment it. Then here I'll define a subshader block. Subshader block is used to divide our shader in parts that targets different hardware and rendering pipeline. For example, if you're developing a shader that targets URP and HDRP, you will write two subshader blocks, one for URP and one for HDRP. Now my project is in URP and that's not going to change, so I'll just write a single subshader block. Now here I can define LOD levels, which I'm not going to do. Then I can define tags, which are just key value pairs. Now you can of course define your custom tags here, but there are predefined ones such as rendering pipeline equals universal pipeline. This tag indicates that okay, this shader is targeted for URP. Then there is render type tag equals, let's say, opaque. Now this tag is more or less only a debugging tag and it doesn't have that much impact on the actual shader instructions. Now there are other predefined tags as well, like for rendering queue to enable or disable shadow casting. You can of course look that up in the documentation, but for now I'll just use these two. Then here I will define a pass block. Pass block is where your actual shader instruction will go. You can of course have multiple passes within a single subshader. For example, you could have a pass that calculates the basic color and light data, and another shadow casting pass so that this current geometry will cast the shadow. Or if I were to apply a per object or per material outline, I could have a custom pass for that as well. Then here you can define a name. Let's call it unlit pass. Then here I can also define the tags. Of course you can define your custom tags here as well, but there are predefined one here as well. For example, light mode equals always, which means always render this pass and don't calculate any lights. Now this is the default value, so if you don't write this tag, this always will be the default one. Now here you can set some GPU commands. For example, you can set blending mode here, or depth test mode, cull mode, etc. But for now, let's just keep it empty. Then here we will finally write some HLSL command, and for that we will go HLSL program and end HLSL. And within this block, we will write our vertex and fragment shader. First I will go hash pragma, then vertex, and I'll give a name of my vertex shader, so vertex, And this is just a name, so you can of course give any value here, but a vertex makes sense. Similarly, I'll go hash pragma fragment, and then I'll call the fragment shader function fragment as well. Then I will define them both here, so void vertex. Then fragment shader always returns a color value, so vector 4, so I'll go half 4, which is vector 4 with 16-bit float precision. You can of course use float 4 here as well, but I will just go half 4 fragment, and then I'll tag it with sv underscore target and open close curly braces. For now, let's just go return half 4 of, let's just return a red color. Oh, when I made a typo here, so it's just render pipeline. And let's just get rid of this tags for now as well, because that's the default one. In the Unity, my cube is just disappeared, and I don't have any error in my shader file, but I can't see my cube as well. And the reason is, I would just tell my GPU to draw the geometry red. I haven't specified where on the screen it has to actually draw the geometry. So let's fix it. So in my shader, I will define a structure, so struct, let's call it attributes. And I'm calling this attributes because the actual geometry will have some attributes attached to it. For example, vertex position, normals, UVs, etc. Here I need vertex position, and position is vector 3, so I'll go float 3 position, and this position will be in object space or local space, so I'll go ls for local space, and then I will tag it with position semantic, which tells our CPU where to look for the vertex position in the actual memory space. Then I need to pass this data to my GPU, and I can do that by just defining a attributes parameter in my vertex shader. Then I'll need another structure. I'll call it varings, and here GPU need to catch that position, so I'll go float 3 position, and here I need to tell GPU where to draw my cube on the screen, so this position will be in clip space, so I will go CS clip space, and then I'm going to tag it with sv position. Then in my vertex shader, I will define varying structure variables, so varings, let's call it output for now, and then I'm going to go output dot position clip space equals to a dot position ls. Now we have a problem here. This position is in local space and I need it in clip space. So to convert this position, we will use a nice function, but to use that I need to include a file. So I'll go hash include packages com.unity.render pipeline universal shader library and core.hlsl. This line indicates that whatever is returned in this core.hlsl file can be accessed in this shader file as well. Then here I will go transform object to hclip, and I will pass a dot position local space. Then I need to return this varying structure, so I'll just change the return type varings, and then I'm going to return output. And I have error. Not all elements of SV position were written. Oh yes, this clip space position should be vector 4, so float 4. And now I have my red cube. Pretty cool. Alright, now let's say I want UVs. and UVs will be defined in our geometry, so CPU needs to read that. For that, we will add another variable in our attribute structure. UVs are vector 2, so float2 UV, and I'm going to tag it with texture coordinate 0, and there are total 8 set of texture coordinates. Make sure to use the one which is not already in use. Then our GPU needs to catch them, so I'll go float2 UV, and I'm going to tag it with texture coordinate 0. And this texture coordinate semantic means that this value will be interpolated when passed from vertex shader to the fragment shader. For example, we have cube, so we will read the UVs of all 8 vertices, and then those values will be interpolated in our fragment shader. I hope that makes sense. Alright, so first I'll go output.uv equals a.uv. Now to output this UV values, I need to catch it in the fragment shader. So in the fragment shader, I will use varying structure as input parameters. So varings v, and let's just visualize UVs. So v.uv, and I have UVs. Now let's say I want normals. Again, same thing, CPU needs to read that, so add another float3 variable, normals. Whoops, normals. And this will be in local space, so ls. And I have to tag it with normal semantic. Then GPU needs to catch it, so float3 normals. And normals are mostly used in light calculation, and to properly calculate the light, normal should be in world space, so we'll catch it in world space. Now we will have normal values for all 8 vertices, but in the fragment shader we also need normal values for each fragment, so we need to interpolate that. So just tag it with texture coordinate, and 1 is unused, so let's just use texture coordinate set 1. Then in the vertex shader, simply go output dot normal world space, and then we have normals in local space, so we need to convert that. So go transform object to world normal and pass our normals in local space, and let's just visualize them. And I have normals. Pretty cool. Now let's say I want to apply the base color of my cube from the inspector, and for that we need property blocks. So let's just uncomment it, and then now here I have to give the name of my property variable, and the naming convention goes like underscore, then Pascal case, and I'll call it base color, then round brackets. Here I can give the name of the label, so I'll call it base color, and then I have to define the type, so color. Then let's give the default value of white, so 1 1 1 1. In the inspector I will have this base color property where I can select any color. Obviously nothing will happen just yet, so let's fix it. Now you might think that let's just simply return this base color in the fragment shader. Let's try that. And I have error because my HLSL program doesn't know what this base color is. So I need to define it in my HLSL program as well. So let's just define it here. And the color is float4, so let's actually go half4 underscore base color, and make sure you give the exact name of your property. And now to make our shader SRP batcher compatible, we need to write all our material property within C buffer block. So here I'll go C buffer start, and then I'll go unity per material, and here go C buffer end. So this will make our shader SRP batcher compatible. SRP stands for Scriptable Render Pipeline, and SRP batcher is a technique to optimize the draw calls to improve our shader performance. And now I can change the color from the inspector. Pretty cool. Alright, now let's say I want to apply the texture from the inspector. So I'll need to create a property. Let's go main text, and I'm going to call it main texture. Its type will be 2D, and let's give a default value of white, and then just open close curly braces. And as soon as I hit save, in the inspector I will have this main texture property with this texture slot and this tiling and offset. Now properties can also have attributes. There are like 7-8 attributes. You can look it up in the documentation. For now, let's just say I don't want to use tiling and offset, so I can use no scale offset attribute of the main texture. So square bracket, go no scale offset, and hit save. And the tiling and offset is gone. Now I need to define this main texture in my HLSL program, and texture require two things: the texture asset and the sampler. So here, let's go texture 2D, and then I'm going to pass main text, and this texture 2D is a macro that simply says, okay, this is the texture. Then I need to define the sampler as well, so I'll go sampler, then pass sampler underscore main texture, and here make sure you go sampler followed by this exact property name. Then in the fragment shader, let's just sample the textures. So go have for text equals sample texture 2D, then pass in the texture main text, then need to pass the sampler, so sampler underscore main text, and then need to pass in the UV coordinates, so v.uv. Then multiply the text with our base color, so text, and here let's just assign a texture. Let's try this checkerboard texture, and I have this texture. Pretty cool. Now if you are like me, you will find this curly braces a bit odd and surely want to experiment. And if you delete this, obviously nothing will happen, everything is working fine. Then you will obviously think that this Digvijay guy is really crazy. He said that curly braces is required, but everything is working without them just fine. Yes, everything is working fine, but it will only work until you don't define any other property after your main texture. For example, if the base color is defined after the main texture, now I have error in my shader, parse error, syntax error on line 4. And line 4 is my base color property, which is just fine. So to keep your sanity, please don't forget this curly braces. Alright, in this main texture property, let's get rid of this no scale offset property attributes, and I will have tiling and offset. But if I change it, nothing will happen. So let's fix it. So to make this tiling and offset work, I will go to my C buffer block and define a new variable, half4. Then I'll go underscore main text. Make sure you give the exact name of your property and then followed by underscore st. Then in the vertex shader, instead of simply passing our input UV, go transform text, then pass in the input UV, so a.uv, and pass in our texture name, so underscore main text. And now the tiling offset will work. Pretty cool. Now let me tell you one thing, which I should have told you at the start, but I forgot. Anyway, if you find that writing shaders is a lot more convoluted, I have to point out that the streamlined way of creating shaders is using shader graph, and it is somewhat industry standard as well. Like in Unity we have shader graph, In Unreal, we use nodes in Material Editor. In Blender, we use nodes. 95% of the time, you can get away with just shader graph. For remaining 4%, you can use custom nodes where you can inject your custom HLSL code. There are only 1% extreme cases where you need to write the entire shaders. For example, remargin. Alright, I will end here. In the next video, I will show you how to tackle transparency. Stay tuned, and I'll see you in the next one.